morning engineering 2 subject. That should wrap up tolerances now. Let me close this. And this is your next homework. Let me get some more water. Let's take a look at your next homework. You are to create, let's see, let me make a dimension sketch. Oh, this one is another sketch. Guys, let me take a look at it. Model and create a fully dimensioned V-size drawing of the part shown below. Please adhere to the following guidelines. Make a fully dimensioned sketch of the pulley cross-section on engineering computation paper. If they want you to do a sketch that is full section, for that we will have to talk about what is a full section. All radio dimensions should be given as diameters. This will help you understand the geometry before modeling it. Staple the sketch to your drawing. You're not going to staple it, you're going to submit a PDF for your sketch. Make sure you submit a PDF for your sketch, otherwise your assignment is incomplete. The sketch is worth 10 points. This must be done first. Consider the pulley, consistent central hull and rim, and a flat circular flange that connects the rim to the hull. Okay, so we gotta understand what is sections, right? And then most likely after we understand what is section, we'll come back to this and we'll try to understand the geometry. So let's go back. Let's understand what is sections and what do we need. What do we need sections? Because if not, we're not supposed just to put sections like per se, right? There is rules. There's a reason. I want to hope that you guys have you're grasping the concept that whatever I'm teaching you for a reason, not just for teaching. It's not dimensioning, not just click, right? Gotta think a little bit. All right. So why do we need sections? If you guys recall, every time we dimension, I have told you need to dimension where the feature belongs, where the feature is. You dimension where the thickness, where I could grasp it. You dimension the hole where you can see the hole. You do not dimension to hidden features. Now, let's take a look at this example. So, for example, in this example, I have, it says to me, it's kind of like a box, and it has one slot on both of the sides, and it has a certain thickness and something's inside of it, right? I don't know what's inside of it. It's actually start looking at the views. And based on the views that I have seen, it seems to me that it has a cylindrical protrusion, top and bottom, and it seems to me that it has a hole that goes all the way through, right? Now, I have to dimension this. Okay, let's go here. Let's say that I assume this guy to be my datum. And then I say from the bottom to the top. So in my case, I can go over here and get that dimension. And then I can go, I don't know, I gotta dimension that guy. Right? And then I can also dimension that guy. And you're like, oh, Professor Calona, but you told me that you cannot dimension to hidden lines. Correct. This is wrong. I cannot dimension to hidden features. So we gotta find a way to dimension to hidden features. A fundamental rule of dimensioning is that we never dimension to a hidden line. So how do we dimension apart the ones that are shown above? Okay. In order for that, we need to introduce you to what we call the sections. The answer comes up from an imaginary cutting plane that it cuts the same shape that I showed you below, and it cuts it into two parts. Once I cut it into two parts, I can separate the part into two sections. What I will display on the drawing will be this. Okay. Let's actually read what it says and then we'll discuss it more. The answer is that we make a section view in which we cut away a portion of the object to reveal the hidden features. We define the imaginary cutting plane and a separate part of the plane so that we can see the inside of the part. So how do we show it on the drawing? Okay. So I have my part like that. And I need to reveal the part. I'm going to create a line which is going to be the section cut line or a cutting plane line, and it's going to be a thick line, sometimes as thick as the visible lines. Or I've seen it even thicker, right? So thick hidden lines, dark, right? Number two, you're going to have an arrow, and the arrow is going to be pointing at the direction of what I'm looking at. So, for example, let me see if I can go over here on the previous one. That is like if I were to go standing up over here and this is my face, and I'm looking that direction, right? So I'm looking that direction of sight. Or like if I were to be standing on top of the block, looking upwards. So you put the arrows in the direction of what you will be seeing if you were to remove that line, the chunk of it. Okay. Now the view that you reveal after you get rid of this, right? Because remember we separated, right? And what I want to reveal is this guy. That guy gets to be placed against the direction of the arrows. For example, the arrows are pointing this way, which means my view will be placed on the opposite of the direction of the arrow. Hopefully that makes sense. I also need to identify the what is going to be my section cut, because I can have multiple sections in a single view depending on the complexity of the part. And in this case, you guys will notice that it has an A. This is what I'm doing. I'm identifying this section and I call it section AA. And then when I place the view, which in this case is the one I'm placing right there, I'm going to name it section AA. And if I were to have another section somewhere over here, right, my view will be placed here, opposite to the direction of the arrows. How am I going to call it? Well, I gotta label it, right? It's called section BB. So in here, I would say section BB. Hopefully that makes sense. Let me get rid of all this mess. Section BB, that one, get rid of that one, get rid of that one, get rid of that one, and that one, and that one, and all this mess that I used. That was it, right? Okay, now I'm revealing my part and I can start dimensioning. So I can go back. Let's say now that I have this as my data, let's call it a part. I can come over here, boom, and boom, and boom. Keep in mind that my section view contains no hidden features. For clarity. Now let's read what it says. The current plane lines shows where the cut is made. Yeah, that's why you see it right there, right? Remember, it looks like a hidden line, super thick. The current plane arrows show the direction of the sight. The section view is always opposite to the way of the arrows that I pointed. Yep, that's what I showed right there. We identify the current plane line and sections with the capital letters. Yes, everything in your drawing should be capital letters, nothing lowercase, including your name, nothing. Everything uppercase. All edges that should be created if we actually physically cut the part are shown as object lines. The material that is cut by the current plane is identified with the thin slanted section lining. So again, once you cut it, you will be able to have now visible lines. Again, sometimes visible lines also you call it object lines, right? So all of these that I just cut, now it's visible because I cut the part. So you will have to make it thick. Now, in order for me to identify the things that are behind it and the things that are in front where I cut the part, and also to identify that I cut the part, I use section lining. The section lining right there is usually thin, while the object lines are thick. Hopefully that makes sense, right? The material is cut. Material that is cut by the cutting plane is identified with the thin slanted section lining. There are no hidden lines in the section views. This is a big one. I've seen many people putting hidden lines on a section view. You don't put no hidden lines. The whole idea is for clarity, right? Okay, let's take a look at a couple of examples. So this one, I create a section view on the top. I am looking that way. That means I'm looking that way. My view should be on the opposite of where I'm looking. In this one, I'm cutting a section view in the front view, right? So I'm looking down and left. I'm being left with whatever is down the cutting plane, right? Which is what you guys see here. I'm looking down and placing my view opposite to the side that I'm looking at. This one has two. All right, that's why you gotta identify them. This one is section A, and then this one is section B. It seems to me both of them are cut in the top view, so you will see it section BB right there, and you got section AA right there. Section BB is the longitudinal section because it's along the length of the part, and you're going to place it opposite to the direction of the arrows. Now, in terms of the section views that sometimes are placed on the top view, like this one, if I were to place it somewhere over here, you can. Um, you can actually, probably that would be the best way to do it. But sometimes certain books will say, you know what, that would be like if I were to look at the side view, right? If I were to look that way. And they say, you know what, I am going to just place it as if I were to be a side view. Now, there is a way of doing it in the model. We're going to most likely, we're going to learn how to do this fully cross-section, your assignment homework 13, most likely when we come back from spring break. Let's look at a couple of examples of what is good and what is not good. Example, the first one is this one. You're looking that way, which means you're looking this way. Your arrows are that way. Your view should be on the opposite side. All of them should be visible line, a bunch of section line. That's the correct way of doing it. Right? Second, I'm looking this way, right? Which means I'm looking that way, which means my view should be on this side. And they place it in the correct side, so that one is wrong. And it seems to me this guy is similar, right? Arrows should be pointing to the left. Either or, right? Either I grab this part and I put it on the other side, or I put my arrows that way, and then I put my part that way, right? Remember, your view will be opposite to the direction of the arrows. Okay, so here I have another examples of what should be correct and what is not correct. Let's see. This guy, this guy, if I were to call it, and I were to call it this direction, right? I would put my section A, right? Which will give me this. Okay, so that one is to me is okay. So check. This guy, you need to displace the visible features after you have cut, right? So that one is wrong because it doesn't have it. This one has hidden lines, and I told you section lines shouldn't have hidden lines. These guys should be visible. Visible lines right there, right? So remember the section, the object lines should be visible lines. All of these that I've shown that hidden should be visible. And what is wrong with this one? Well, this guy has hatch lining that looks this direction, and then it has hatch lining that look that direction. I hope you guys could see it. When you cut a part, you can cut it on a part itself, or you can cut it at an assembly level. And when you have an assembly level, that means you cut multiple parts. You cut in a section of an assembly. And the way you let know what is the difference between different parts as you cut the assembly is by having directions per part, let's say. So one part will have hatch line in that direction, while the next assembly part might have hatch line in that direction, while the next part might have it at a different direction and a different, let's say, it might be a different angle, or it will be a little bit more close together. But every part should have a similar hatch arrangement, similar pattern, right? So you guys will notice that here the top pattern and the bottom pattern of the hatch lining, it's different. So that's why this one is wrong. Now, if we were to talk about all the sections, that way you can also do the rotating section or revolve sections. There are many types of sections. Let's list them. Full sections, offset sections, half sections, broken out sections, sometimes also called breakout sections, revolve sections, remove sections, auxiliary sections, single sections, and assembly level sections. Am I going to cover all of them? I gonna hope I have enough time to cover them all. If not, this is an introductory class to graphics per se, engineering graphics. It's actually introductory, but you guys learn a lot. By the time of this, by the end of this class, you're going to be like well versed. We want to try to cover all. We want to do them all. We might, let me see, which one we want to do in the class. We want to do this one. We want to do this one. This guy I don't remember. Okay. We want to do that one. We might do this one. I don't remember. I'm not 100%. We might do this one. Auxiliary section, you're going to do it. Single section, you will not do it. And assembly section, you will do it. Right? And again, how you're going to learn all of these type of sections? You're going to learn them by doing them. For now, we're just going to talk about them, and then eventually we'll do them in the assignment. Let's take a look at the first one. Full section. How do I know that I have a full section? By the way, this is the type of section that you will do here. This is not a full section, by the way. I cut the part like a quarter of it. That is not a full section, right? A full section is a section as if I were to grab a plane and cut through the whole full length of the part. We call that a full section. Like the previous example that I showed you in the previous slides, they are called full sections because I cut through the whole full part. Let's see. If I were to create a side view, this guy will be a mess. I don't understand what's going on. But if I create a section, it's nice and clean. I understand exactly what's happening. If I'm creating a full section, I need to create a section line cut that will go through the whole part completely. That's why it's called full. You reach through the whole thing. And you have the arrows pointing that way, which means my view is opposite to the direction of the arrows, like this one, right? Easy. Full section, easy. We just did a bunch of them. Half section is a little bit more tricky. Okay, so let me get some more smart water. In the half section, we don't cut all the way. We cut half the way. So instead of me going and making a line that goes all the way through, and then say, okay, I'm going to cut the whole thing like that, I go half the way. That's why it's called half section. So I'm going to go down, I'm going to cut the part here, halfway there, and then if you guys want to put this in the model, by the way, because we're going to do it on the model, I need to move away. I need to go that way, like this. So it's kind of like removing, I don't know, like a quarter of it, and then looking at it. So let me show you how it looks. Again, I went down. Again, I'm looking that direction, right? I went down to half the way, and then I move sideways. That will allow me to generate a quarter, and I'm removing the quarter and get rid of it. I mean, I don't get rid of it. I'm just kind of like move it on the side so I can have the things for clarity. Now let's take a look at what I see when I have a half section. Well, first of all, you guys will notice that you have the arrow on only one of the lines. You don't have an arrow on the other side of the line. The arrow tells you what are you looking at. The direction of the arrow is that way. Again, because the arrow is pointing that way, I'm going to put the view opposite to the arrow direction. I'm still going to have my section line. I'm still going to have my visible features, my object lines. I'm still going to have my section lining. And in the section where I have removed it, I will not have hidden lines. Now, you guys will notice this line right there. You are not going to display it. See, you are not going to display a solid line there in the middle. In fact, it's a center line to represent that you have cut a section and move away, a quarter, move away. Most half sections, they are usually done for cylindrical features like the one that you see above, right? Such that you can see the center line right there. See it? The center line right there. And that's why when you go and you create the section line, you are not actually cutting the part. This is the portion where the center of the axis is. So you show it as a center line. Then everything below the center line, I did not cut. Now, this is your prerogative. You will display the hidden lines in the part that it has not been sectioned if you feel that are necessary for view interpretation per se. So for clarity. If you believe that the hidden lines will help you in terms of clarity, you leave them. If you believe that they are not clear for clarity, then no, you don't leave them. And again, it's a one-to-one basis. In my case, I believe it might help. Right? I will say in this example, it makes sense to leave them. Okay, let's review. Section views are done because you need to be able to communicate your design intent and dimension to where the features belong, where they are. You create an imaginary plane that cuts through the part and allows you to reveal those features, such that now I can dimension. Usually, you place your view opposite to the dimension of the arrow. You got object lines. You got hatch lining, which is thin. Your section line usually thick, and you also usually label them. Full sections go to the whole part. Half section go halfway of the part. You remove that section. The view is still opposite to the direction of the arrow. And in this case of half section, you will do the same thing that we did before, just accounting that the center should not be a visible line, should be a center line. And everything that is below will have hidden lines if it's necessary only. Let's take a look at what happened if you were to be cutting a rib, because you also have standards, makes it a little harder. So, by the way, what's a rib? What is a flange? What is a web? What is a hub? So let's talk about a little bit about what is a rib. Okay, the ribs, they are like gussets. What's a gusset? A rib or a gusset, they are there placed so the things that are slapping, like slappy movies, for example, some of these parts that look like an angle or something that has a thing that can deflect sideways, like this, right? And again, what do they fly sideways? Maybe because there is a load, right? It makes it go flippy, right? So what they do to prevent this flippiness, sometimes they put a gusset. A gusset is just a piece of metal, piece of material. Usually the gussets, you call them gussets for metal assemblies per se. The ribs, you usually use it for when it's already part of your design. For example, like for extruded plastic parts, not extruded plastic, but for plastic parts that you already usually have a mold. Usually the ribs are already there, right? It's all in one homogeneous part, not multiple parts like in metal that you gotta weld the plate. Um, so the ribs are pretty much gussets, and you guys will notice that this little triangle right here, I don't know if you guys can see it, the little triangle right there, is meant to withstand and make the flippy little thing here, this one, right, a little bit more rigid per se, right? So that's when it comes to flipping, right? That's a rib. Where's a flange? Well, the flange is a flippy thing. So, for example, before, this is a flippy thing. Okay? That's the flippy thing. Goes like that. If you were to go and look at I-beam, sometimes they call it Y flange beam, sometimes they call it I-beam, depends. There are some of them they call it rails. Again, these guys, they all look like eyes. And the difference with the I-beam and the Y flange beam is that the flange is bigger. That's what's called wide flange. So you have a longer, wider flange. But flanges, what are flanges? Flanges is the flippy thing. This guy, that's a flange. And other one, I have another flippy thing here on the top, that's a flange. Another little flippy thing on the bottom, this guy is a flange. And the flippy thing on the bottom is also a flange. The web is the unsupported, let's call it the supported on both sides member. So for example, this flange is on the top, right? I have another one on the bottom. The one in the middle is called a web. It's like web, like internet web browser. It's a web. It's like that. Okay. The top is called the flange. The middle is called the web. Hopefully that makes sense. You can also have logs. You can also have gears. Now, when we're dealing with ribs or with gears or with webs or similar features, we have a standard of how we show it. Okay. And again, we do it for clarity, to be able to see things better, more clearly. For example, in here, let's see if I can draw it. And again, sorry, I'm drawing with my mouse, so it's a little bit harder. So I'm gonna draw it. It's like this, and then I'm gonna have something like that. And it seems to me make it a little bit more curvy, like that. Actually, this one should be straight, put it like that, and then it goes straight like this, and then it goes like that, and then we go like that. It seems to me this guy goes like that, and then this guy goes like this, continues this way, that way, that way. Okay. That is my masterpiece of art. Hopefully it makes sense. And I just seem to me got a couple of holes on the bottom, right? That represents your part right here on the top. Okay, so I go and I start creating a section. Now, if I were to cut the part, and I go and make a full section, you guys will notice that I'm cutting through this web. Again, this is the web, right? And in reality, if I actually were to cut, it will look like this. Now, that makes it hard for me to understand what actually is happening. So, by standard, what we do is we don't cut the webs. So, if we imagine as if we were not cutting it, and you guys will notice that there is no hatch there. So that's the correct way of doing it. It's like if I did not cut it, right? So you show all of this, all of that, and you don't show the web, which is just like that. That's the correct way of doing it. Let's take a look at another ones. Also, when you have things that are revolved, right, they have not a nice angle, and I need to display them. For example, like this one, right? I went and I cut the part all the way through. And if I were cut the part, this is my section, how it will look. So we don't display it like this. What we do is we create an imaginary path as if that hole will be here. We know that it's not there. Okay. And then what we do is we project the lines, right? Project the lines like this, so that I now have the location of the hole as if it were to be revolved around on the projection, on the cutting line, which is something like this one, right? See, right there, they got projected. Now it leaves as if it were to be there. It's not there. And then we project it over here, and that is my conventional practice to display a hole that doesn't live in the cutting plane. Let me see. Do I have more examples? Oh yes, I have more examples. Okay. For example, here I have a rib. And again, remember the ribs are usually, you can also call it a gusset, but the ribs are usually the ones that already are homogeneous to the part, right? So that means when you manufacture it was already there. Okay, so here I have a rib, here I have another rib, and here I have another rib, right? And if I get to, you guys remember, I told you we don't section two ribs. So that guy should actually look like that, no section lining in the middle. Well, I also have another situation here where this rib is not parallel or in the line of the section line. So what we do, we imagine it as if it were to be rotated along in the section line, and then we put it right here. Again, I get rid of that line that doesn't exist. Well, it exists, but we imagine it as if it were to be revolved. Now, I also have the same concept with these holes. You see that hole right there? That hole doesn't live in the section line. Well, guess what we do? By convention, you grab it, you revolve it around as if it were to be here, which I know it doesn't live there. I'll still show it. And it will look something like this. Boom. Now, how will it look by the end? Will it look like this? Right. By convention, we don't cut to ribs or flanges. And then if we have some holes that are not on the cutting line, we revolve as if they were, and then by convention we show them, which I think it makes it look so much clean and clear. Hopefully it makes sense. I think I'm going to leave it like this. We might talk about the other ones, but I actually, next time when we come, we need to talk about your homework 13, which most likely will be when we come back from your spring break. Okay, so let me stop the video. And you guys have the in class, which is this one. Right. I'm gonna grab a system that is an inch part. So I'm gonna grab myself an A-size sheet and an inch drawing from my Dropbox, and I can let you guys do the same thing. I want to go grab a couple of things. So I want an inch part and I want an A-size drawing. Okay, put that one in there, and I'm gonna call this guy homework 13 extra credit part. And I'm gonna call this guy extra credit drawing. For your extra credit, you guys don't need to submit your part and your IDW. Only want the PDF. Let me open this guy. Let's take a look at the drawing while what the inventor is opening. Thomas, how will you model this?
How we start with circle,
Circles? Ricardo, how would you model this? So going back. Any idea? How would you model this? With the one? the middle view between the two circles. You guys don't have the tools to do this one. That's the problem. I need to give you new tools, right? You only know which one. The sketch and extrude and holes and fillets. That's all you got then. You need more tools. I think I also give you the mirror, and that's all you got then. You need more tools. So let me give you more tools. You guys need, there is a command that is called revolve. So you're revolving around. The only thing that you need is a sketch and an axis to revolve around, right? You have a sketch over here and you revolve it around the axis. So the hardest part of this drawing is to come up with this sketch and then revolve it around this axis. We generate something like this. Then make a couple of holes and rate those holes and you're done. Right. It's not too bad. Just have to by doing this freaking revolve. Let's try to do it. Actually, let's take a look at your. No, let's do it, and then we will take a look at your homework. Okay. All right. So, I need to clean up my mess from my template. I need to choose a sketch where I'm going to start rotating. Right. What is my sketch going to be? And again, if you, as I previously told you, each little sketch is going to become a sketch here. It's going to revolve around this axis. You're going to walk around it. Okay. So I need to create a sketch. So let's focus on the sketch. I am going to go to this plane, and I'm going to say new sketch. Seems to me that it has like a line like this, then it goes like that, then it goes like that, then it goes like this, like that, then like this, then like that, then like that, then like this, like that, and then it finally closes. Let me close this line. Right, something like that on the top. Right, Thomas? Not too bad. The problem is that my sketch looks like kind of like iffy and all over the place. So I need to make it look black. Remember, it needs to be black, otherwise it's not done. So let's get a couple of things going. The top of the part seems to me that is 1 inch. I'm gonna come over here and I'm gonna get 1 inch. We'll make everything grow. I need to put the least amount of dimensions so this guy gets to be drawn. So what I'm gonna do is I'm gonna use a bunch of constraints. I'm gonna use the equal constraint. I want this guy to be equal to this guy to be equal to this guy equals to this guy equals to this guy, and this guy equals to this guy. Just equal everything, right? Okay. Now I need to get a couple of thicknesses. This is 0.25. Actually, let's not do it like this. Let's make it even easier. I want to make it a little bit different. I want to make this guy out. To make a line like this. Like that. Right. I'm doing half of it. I'm gonna grab this line that is there, and I'm gonna change it to. So I don't want to change it. I'm just going to align it so it's vertically with this axis. I want to say that line, that point has to be vertically with this point. And that will align it. Just make it so it's straight that aligns with your plane. I am going to change this line and I want to change it to a center line. Let me tell you why I'm going to do that. Because once I make it into a center line, this guy will allow me to measure distances, kind of like a symmetrical distance. To be honest, I'm not going to do it like that. I think there is a better way to do it. I'm gonna change this guy to construction, and I'm gonna use the mirror. What's the mirror? Mirror command in the sketch mode. So I have a mirror line, and I'm gonna mirror all of these to the opposite side. So I'm just gonna select this and this and this and this and this and this and this, and then I'm gonna say I wanna mirror it with respect to this, and then I'll say apply. Boom. What does the mirror allows me to do is if I change this distance, the opposite side will move at the same time, right? I think that's the cleanest way to do it, right, Thomas? I might not be, but I want to make the dimension of this to this 1 inch. I'm going to make the dimension from here to here 0.25. I'm going to make the dimension to 1.5 over here. From here to here is 1.5. Then right after that, I have a bunch of diameters, right? So actually, this is the point that it would be a good idea to create a line. Okay, this line that is there. I need to lock it to the plane because that won't be my. That one will allow me to create like diameter instead of trying to go and divide every dimension by 2. It will allow me to create like diameter. So I'm gonna align this guy to the plane, and I'm going to change the line type to a center line. Center line. Everybody got what I've done? Okay, so the whole idea is to come up with a sketch. The whole idea is to come up with a sketch. And I need us to do different way than I did it. You don't have to actually do it exactly like blindly what I did. At the end of the day, just come up with a sketch. Right? I just decided that maybe I should teach you how to use the mirror sketching. And I decided maybe I should also teach you why to use this like that little as a center line. That's what I did. That's what I might do at the end of the day. At the end of the day, just come up with a sketch. When I created this line and I made it a center line, I just did right click, center line. So again, it's been not left click, it's right click. What would this allow me to do is I can get these dimensions out. I can get this outer diameter to be 4 inches. I can go from here to there and make it 4 inches. I have to drag this guy down. I just drag it, grab it from the top, move it. It is mirrored, so everything will update automatically. It seems to me that the next one, it is 3.75. So I'm going to get from this point to the center. And you see how it opens up? It kind of like finds where the next point will be. I don't have to do over 2. 3.75. The next one, it is 3.5. So from here to there is 3.5. The next one is 1.5 and 1.25. From here to there is 1.5. And the last one from here to there. Oh, sorry, no. That should be 1.25. And this guy should be 1.5. And then I got a hole that goes in there, right? See this hole? Oh, the hole I want to do it using my hole command. I don't like to use. I don't want to do a revolution of a hole because otherwise I cannot get my center lines to be automatic. Right? So I'm just going to align this guy. I'm going to put it, align it, and I make it align to that guy. I'm going to say align this guy to that guy. Boom. And again, I am waiting for my sketch to be completely black. If it's not black, it is something that I'm missing. It's completely black, right, Thomas? Okay, good. So I'm going to say finish sketch. And then I'm going to use the revolve command, stuff that you guys have not seen. You're going to say right click, revolve. Where's the peanut butter inventor? If it's not left click, it's right click. Simple, right, Thomas? Thomas 1 and Thomas 2, simple. So now I found the profile. Now it's asking me select an axis. I am going to go here to my axis and I'm going to start looking for the axis that I want. Actually, come over here, select it. I want to get this axis. What happened? and revolved around it. The whole thing just revolved around it. 360, that's what I wanted. And now I have my part. Take care of it. I'm going to save it. Now I need to start messing up with there's a couple of holes. I got a couple of holes going on. I got a 3/4 hole going in the middle. I'm going to say right click. I want a hole. I want to place it in this view. And then I want to make it concentric. And then I'm going to make this guy 0.75. Say okay. Then I have another hole that I need to array. See it? I need to array it. So I'm going to come back on this face and I'm going to say create a new sketch. I'm going to make a point. I'm going to put it right there. It's flying in the sky, so I need to constrain it. I'm going to make it vertical in this axis. And then I need to give it a distance. Distance from here to the hole. And it seems to me that is 2.5. Bold circle, which means a radius of 1.25. Right? It's just the bold circle. It's the circle that has bolts. That's what they call a bold circle. Then I'm going to say finish. And then I'm going to do the hole. I should know what hole it is. I just need to change the size to a half. Come over here, make it a half. Say finish. Right there. Right. Now I need to do 6 of them. Right. So I need to array. I'm going to go to my pattern. I'm going to click circular array. It's asking me select the feature. I want to select the feature from there. I could also select it from here. Right. And then it's asking me find the axis of rotation. So guess what? I'm going to select the same axis that is there. And then it's asking me how many you want. I got 2, 4, 6. So I'm just going to say 6 of them. So I'm going to say okay. I got my part in there. I got a few fillets going on. I got see how many fillets I got. I got 1. I think this one's a fillet. All these 3 insides. What is the size of my fillet? Fillet. 1/8 fillet. So I need this guy. Fillet. 0.125. I need this one fillet. I need this one fillet. Shift middle mouse button to go to the other side. I need this one fillet. I need this one fillet. And I need this one fillet. And then I'm going to say, okay. All right. Easy money, Thomas. Right? Not as bad. The only thing that is, the only problem was that you guys didn't have ski. You know the little revolve. Now that you know the revolve, you're like, oh, I know how to use it. Now, guess what? You're going to have an assignment that is going to require to do what? Revolve. Okay. So now let's place these views. If you watch the lecture, I talk about sections. This is a full section view. Fully sectioning, fully cut into the whole part. Okay. So I want to create this view. I want to put it in there. Right click, base view. It has a scale of 3/4. Does it have a scale of 3/4? No. If I go and I want to place a side view, so let's put it in there as well. It doesn't look like mine. I feel like I did something weird. Tell me that this one might not have a fillet. Let me check. Let me check this fillet, edit fillet, and I'm gonna click on this guy. Shift, click on it to remove it, and shift, click on it to remove it. All right. Now let me double check on the drawing. Yep, I did not have it. What happens is when you go and you have a fillet and you do a view, it doesn't know how to represent an edge, so it doesn't show it. Just shows you like nothing that is there. So in other words, so you guys that are doing this modeling, there is no fillet right here, okay? No fillet, and there is no fillet over here neither. Okay. Now I have a couple of features in here that I cannot dimension to, right? I cannot dimension why, because it's hidden features. Hidden lines, I do not dimension to hidden lines. I need to have a view where I could dimension stuff. That's why my regular right side view will not do the trick. I need to get rid of it and I need to create a section. I am going to see if I can get a couple of center lines before I create my section. I'll make center lines and I'm going to say create a couple of them for me. Oops, what's happening with these guys? Do these guys look like this one? No. Shoot. I need to do a little bit of tricking here, right? I need to, if you go to the annotate tab, you will see a little circle with a quadrant with a bunch of points in there. That one's the one that you're going to use. You click on it once and then you read what it says. Select the center of the circular pattern. You just need something circular to start going around. Let's say that guy. Click on location. That guy, that guy, that guy, that guy, that guy, that guy, and that guy. Right click and create. Boom. It's good, huh? It's good. Then I have these center marks. I'm going to go back to this guy and I'm going to click on the outside one. Boom. Let's create this section. I'm going to go to the place views, and then where you have all these views, you have one that says section. Just click on the section and then you read the command. Select the view. That's my view. Enter the endpoints of the section. So it wants to know where you want to cut. And I want to cut to this part. I'm going to go through, I see my quadrant, and then I'm going to move upwards. You will see like a little dotted line. Click when you see the dotted line. Then go down. And then you right click and you say continue. Now you gotta place it, right? So place. I want to place it about here. And it seems to me that it brought my call out. And I don't have my call out, and then you do just like mine, right? So I need to remove it. Remember, it's just like mine, not like yours. I take it off. So I'm gonna click on it, and I have a little light bulb in there. In fact, if I go to the little pencil, it will say you want to change the section view and the scale. The view name, they get it from this B, right? And the scale, it gets it from this one over here, right? But I don't want to show it. I'm just going to say, don't show it. Take away the little light bulb. And then I'm going to say, okay. Now let's get. Now I am going to go again. I want to see how many center lines I can get. I don't many center lines. Click, and boom. Now, let me see if I can make this guy just a little bit. I think some of you guys run into this problem last time, right? When your center lines were a little too little. So, when you go and you right click, you have the edit center mark. When you go and you do any dimension, let's do a dimension. From here to there, and you right click, it will give you edit dimension style or edit center line, anything in terms of edit. Okay. I am going to actually mess with the center line, center mark. I'm gonna wait till this guy pops up. Okay. You have a center mark style. Okay. You can create new center mark styles. I'm gonna keep it as it is. I'm just going to mess with the numbers. I think what I'm going to do is I'm going to multiply this whole thing by 0.5. By 0.5 by 0.5. See what it does. Boom! Right in the middle. 0.5. Everything halfway. Okay, I like it. Let's what do I got? I have a couple of callouts here. Say you got 6 of them, diameter through on a 2.5 volt circle. When you have a cylindrical part that you need to dimension, you do not dimension with datum because there is no datum, right? The datum that you use is an axis datum. It's not a plane datum. In other words, you go from the axis and move out from the axis. Okay. So if I want to move out from the center of the axis towards the outside, what would I see? And that is the reason when you go and you see these dimensions, you go from in to out. From in to out, right? So the first thing that you see is this hole, and it has holes right here. This is a true size. I could also dimension over here because I was able to break the rule now because I have a section. And my section will allow me to dimension. As long as I cut through the whole thing, I'm able to. So now I go to the next feature out, the next feature out, the next feature out, the last out, and then finally here I have the dimension of the outer boundary. Let's do those ones. So let's do this dimension for this guy, and you have what is this reference? Guys know what is this guy's reference? The little parenthesis does is reference. You don't want to repeat it, right? Every time you repeat it, it becomes double dimensioning. It's already called out over here on the note. So you don't want to do it. You only do it once. The other one is just so you know. Okay, so I want to say reference, double click, go to reference, click OK. And then I'm going to do a whole call out of this guy. I'm going to double click on this. I'm going to say I want 6 of them. True on diameter. Come over here and get this diameter 2.500 for circle. And I think I just call it DC. The way I call it. On 2.5 volt circle. On 2.5 volt circle. Okay. Then you have this outside, which I already have it. Then you got 6 of these at 60. This is what it's telling you here. You got 6 of them. I want to right click. I want to say dimension, and I want this guy and that guy at 6. Double click. Double click. Come over here. Go to the left 6 times. You have this hole, which is unilateral. Means you are only making it bigger. So I am going to I want to say a whole call out. I want to go to that guy and I want to say 0.75 through. Double click, precision and tolerance. Click on this double arrow. Check on the tolerance. Change it to limit stack. It needs upper limit 2000. So let's change the precision to 3 decimals and make the upper limit 2000s above the basic dimension. Now we'll do this. I'm going to trust that you can come over here and do the notes, right? I believe the only thing that you guys might want to know how to do is this guy. Because if I go and I dimension it, if I come over here and try to dimension it, it's going to give me 3.466. Actually, put a symbol of it right there. It's going to give me a 3.466. And this guy is 3.5. And then you guys are wondering why. Right? You guys are wondering why. This is the problem. Okay? Look at that. When you guys did the sketch, remember how it looked like this, right? And then you measure the dimensions. You dimension to this point, to that point, right? And then what happened? So it looked like this, and you dimension to this, right? Again, let me make it a color so you see what I'm doing. This blue, this blue, right? That's the thing that you model. The problem is then you put a fillet, right? Then you put a fillet, and then the fillet became this, right? So now when you go and you dimension, the program is trying to look for, guess what? An arc that is not 90 degrees. It's a little bit off the 90 degrees. So it's looking for a point somewhere there. A point somewhere there that is a little bit below the zero corner. That is the problem. So how do we fix this? We're going to do another trick. A bunch of tricks today. Okay. So I'm going to get rid of this guy. And I am going to go to the sketch mode. How do I go to the sketch mode? L for line, just like AutoCAD. I'm going to click on it, and as soon as I start writing or drawing, I'm gonna click here and I'm gonna put it about Y. Let's make another line. So I'm gonna make it straight. Okay. I'm gonna use this coincident constraint and put it right there. And then I'm going to align this guy to that guy. Okay. To make the little corner. I'm gonna do the same thing on the bottom. I'm gonna make a line here. I'm gonna put it there. I'm gonna make a line from over here. I put it somewhere there. Connect them with my coincident constraint. Then make them align this one to this one. Now, if I finish my sketch, I should be able to come over here and dimension to my sketch mode. From here to there, and I will get my 3.500. Now, if I look at my do just like mine, it looks like mine, but mine has extra lines, right? It has extra lines that I just drew. So I need to edit my sketch one more time. And what I'm going to do is I'm going to highlight my sketch lines. And there is a portion here on your sketch that lets you know what? You can keep those lines. You're able to see them on the sketch only. Nobody else, nowhere else. So I'm going to say sketch only. And then I'm going to come over here and I'm going to say sketch only. And then when I finish, they are there, but I don't see them. Now, you should be able to do the same thing on the bottom here. You should be able to put the rest of the dimensions, put the rest of the nodes. Should be able to do just like mine. Okay, let's take a look at your homework. This is your homework. Easy money, right? Simple. Willow, what do you think? Easy? Simple. This looks like a bunch of weird stuff. You click for what? It's a section. See, that's the whole thing. See your isometric. Cut right in the middle. Yes or no? You guys can see it? Somewhere in there. Ricardo, can you see it? Smaller. Okay. When you guys are doing this one, it might be a little bit cumbersome for some of you guys in terms of the sketch mine. As you guys are working through this, you guys have some instructions. This one. What is it asking you about a sketch? See the little sketch that says on the top? The sketch is worth 10 points. So in order to even do this guy, if you want to ask me a question, first show me your sketch. And what is the sketch going to be? It's going to be a cross-sectional. The same way that I drew it directly on Inventor. You're going to create a sketch such that it looks the same as your well, it's similar. Something like this, but better, right? Something like this, but better. Something in a drawing, in your notes, better lettering, everything nice and pretty, right? Okay? 10 points. 10 points per drawing. Yes.